Okay, so now we're going to go over section 6.2. We've learned in section 6.1 how to draw, shade, and look things up in the z-table, how to find z-scores, how to find area. So now we're going to use that to apply to applied problems that are normally distributed, which is what happens a lot in the real world. A lot of real world distributions are normally bell-shaped distributions. So the standard normal distribution curve can be used to solve a wide variety of practical problems if the variable is normally or approximately normally distributed. So that's really what we're going to do for the rest of chapter 6, in chapter 7, and chapter 8. So the procedure for table for applications of the normal distribution, we first draw the normal curve and shade the desired area, as we learned in section 6.1. We convert the values of x to z values using the formula, the z formula. Remember that z is the number of standard deviations of data value x from the mean. It might be positive if the data value x is above the mean, negative if the data value x is below the mean. X is a data value. Again, mu is the population mean. Sigma is the population standard deviation. So we're going to do some applied problems. Take it step by step. Example 6.6 on page 329 from the textbook, liters of blood. An adult has an average of 5.2 liters of blood. So that is our mean. That is given. That's the population mean mu. An average is a mean. Assume the variable is normally distributed. So that means we can apply our normal distribution tables and formulas, the z-tables, the drawings, all of that. And it has a standard deviation of 0.3. So that's our standard deviation, sigma. Find the percentage of people. So we'll get area. We'll convert it from a decimal to a percent who have less than 5.4 liters of blood in their system. Okay, so the first thing we do is before we draw a picture. So instead of doing the standard normal distribution, now we're just doing a normal distribution with applied data. So the mean mu is in the center is 5.2, and our data value x is 5.4, and less than just tells us where to shade when we draw the picture, less than to the left. So where is 5.4 in relationship to 5.2? It's bigger, so it's to the right. We don't have a really good feeling of how far to the right, so at this point, just put it to the right. So that's our data value x, and we want less than that. And so less than 5.4 liters would be this area up to the mean of 5.2 and all of this area to the left. So we know our answer as a decimal is going to be more than 0.5, 50%. But we can't look up, we don't have a z-score. So we have to convert this data value x to a z-score using this formula, which we got back in chapter 3. So we're going to take x, which is 5.4, minus mu, the mean, 5.2, over the standard deviation, sigma, 0.3. So subtract first, that's 0.2 over 0.3. And so this is going to be a z-score, so we're going to divide this out in our calculator. 0.2 divided by 0.3. It's a z-score. Our z-scores, when we look them up in the table, are rounded to 2 decimal places. So you have to round correctly. You're going to get the wrong answer. You want to round to the hundredths place as a 6. So you look to the right is a 6 and the thousand. So we're going to round up. We're going to call our z-score 0.67. So make sure you round correctly to the hundredths place. If it's a 5, 6, 7, 8, or 9 in the thousandth place, you round up. If in the thousandth place you have 0, 1, 2, 3, 4, you keep it the same in the hundredths place. All right, so there's our z-score. We are not done. What we now need to do is look it up and find the area to the left, which is actually what we want. So that'll be our answer. So as we learned in the last section, we're going to look up 0.67 on the positive z-table. So we're going to go to row 0.6 and over to 700, 0.67, and that gives me the area to the left of 0.7486, row 0.6 and then 700. So 0.7486 is the area to the left. I'll show that in the picture. Is that our answer? Almost. we did want the area to the left, but they did want it as a percentage. So we have to take our 0.7486 and convert it to a percent and write the answer as 74.86%. Alex will tell you how it wants to round to how many decimal places. So that's example 6.6. Let's keep going. And again, you can rewind and rewatch this if you need more time to go back over the example. So this is a real data here for monthly newspaper recycling. Each month, an American household generates an average of 28 pounds of newspaper for garbage or recycling. Okay, so that's our mean. I'm going to put this down to the next page. So the mean is 28 pounds. I think that's probably less now. This example is a couple years old. A lot of people don't get newspapers anymore. Assume the variable is approximately normally distributed. So that means we can use our normal distribution charts, tables, and formulas. And the standard deviation is 2 pounds. So there's sigma. If a household is selected at random, find the probability of its generating between 27 and 31 pounds per month, and then more than 30.2 pounds per month. So we'll take them one at a time. So we have two data values here. We have X27 and X31, and we want the area, which is probability, between. So we first start by drawing our drawing of the normal distribution. In the middle goes the mean of 28. And so now we're going to place those X values in relationship to the mean. 27 is smaller than 28. The mean is not 0 anymore. 27 is smaller than 28, so it's to the left. Not really sure how far to the left, but we'll just put it to the left. And 31 is more than the mean of 28 to the right, a little bit farther to the right than this other one was to the left. And where are we shading between? So again, the picture really tells us how to do the problem. And so now what we're going to do is we're going to convert each of these data values X into a Z-score using the Z formula, which remember was X minus mu over sigma. So we're going to do this twice. So we're going to do this with X is 27. We will expect the Z-score to be negative because we're to the left of the mean. And we'll do it with X is 31. The Z-score should be positive because that's to the right of the mean. So calculating the Z-score for a data value of X of 27, we take X27 minus mu 28 over the standard deviation sigma 2. This gives me negative 1 over 2. If you divide that out in your calculator, that's negative 0.5. Now this is a Z-score, so we actually need a hundredths place. So I'm going to add a 0 on that so I can look it up and get the right column. I'll do this one and then we'll look them both up. So converting X of 31 into a Z-score, we take X31 minus mu 28, the mean, over the standard deviation sigma of 2. So this is 3 over 2, which gives me a Z-score of 1.5, which we're going to look up. So again, we need a hundredths place. Since it doesn't have one, I'm going to add a 0. So now we have our Z-scores. We're going to look them both up to find the area, and then we're going to finish the problem because we want the area between. And we know when we want the area between, we have to subtract to get our final answer. So I start with the negative Z-score of negative 0.50. So it's in row negative 0.5 towards the bottom here. And then all the way down here to over to 0 hundredths. So negative 0.50. So 0 is the hundredths place for the go over to the hundredths of 0.00. We have 0.3085. That is the area to the left of negative 0.50. So 0.3085. So I'm going to go back to my drawing and put that in the drawing. 0.3085 goes here in the left tail. Now we're going to look up a positive Z-score of 1.50 on the positive Z table. So we're going to go to row 1.5 and then go to the hundredths place of 0 hundredths. 0.00 is the column. So that's going to give me 0.9332 is the area to the left, all the way to the left tail from 1.50, 0.9332. So I'm going to put that in the drawing. That's all this, 0.9332. So because we want the area in between, we know we have to subtract, get the difference. Take the bigger number, 0.9332, and subtract the left tail that's unshaded, the area we don't want, 0.3085. And that is going to give me an area of 0.6247. I'll put a 0 in front for answering in Alex. It didn't ask us to convert that to a decimal. Convert that to a percent. So we'll just leave it as a decimal. So the probability that a house will generate between 27 and 31 pounds per month is about 62.5%. But it just asks for probability. So you can just leave it as a decimal unless it asks for it otherwise. In general, it's going to ask you to enter 4 decimal places. Alex will tell you what it wants. So if we go to B, now we want the probability the household generates more than 30.2 pounds per month. So 30.2 is our X. More than is another way to say greater than or to the right. So again, let's draw the picture first. So we can shade what we want. We know how to finish the problem. So in the mean goes our population mean mu of 28. Where is 30.2 in relationship to the mean? It's to the right because 30.2 is more than 28. That's X. And more than that is the right tail. We're going to shade. So now we're going to convert that data value X, 30.2, into a Z-score using the Z formula here. We expect it to be positive because we're to the right of the mean. So X 30.2 minus the mean mu 28 over the standard deviation sigma 2. So this gives me 2.2 over 2, which when subtract first and then divide, that gives you 1.1. Again, we need a hundredths place, so we're going to add a 0 on. That's the Z-score we're going to look up on the positive Z table. Remember, that's going to give us the area to the left because that's how our table works. But in the end, we're going to have to do some work because we want the area to the right. So we're going to go to the positive Z table and look up 1.10. Row 1.1 and 0 hundredths, which gives me the area to the left of 0.8643, the area to the left. So I'm going to go back and put that in my drawing. 0.8643, the table always gives you the area to the left. We want the area to the right, and what we know is that the total area under the curve is 1. So we're going to subtract to get the difference. 1, the whole amount, minus the unshaded 0.8643 is going to give me my difference of 0.1357. Put a 0 in front of that. That's our answer. That is the probability that a household would generate more than 30.2 pounds of newspaper recycling in a month. So about 13.5%. Okay, so let's go to another example. Again, you can rewind and go back to that if you need more time we'll review that. So example 6.8, decibels at a concert. A decibel is a measure of the intensity of sound. The average number of decibels at a full concert is 120. So the average, that's the mean, 120. Assume that the variable is approximately normally distributed. So we can apply all our formulas and tables for a normal distribution. And the standard deviation, that's sigma, is 6. If 100 concerts are selected, approximately how many will have a decibel level less than 112? Okay, so this 100, we're going to come back to that in a minute. First, we're going to find the probability that a concert has a decibel level of less than 112. So our X value is 112. Less than tells us where to shade, and then we'll apply that to 100 once we get our probability. So this, we're going to find the probability that one concert has a decibel level that less than 112, and then we'll apply that to the fact, what about 100 of them? So first do this for one concert. So again, our population mean mu is 120. 112, where is that in relationship to the mean? It's less than 120, so it's over here to the left somewhere. Again, you just don't have a really good idea about how far away, so just put to the left. And less than, you shade in the left. So this should make you all happy because, again, the left shading is always the easier question to finish up. So we're going to convert our X value of 112 into a Z-score that we expect to be negative because we're to the left of the mean. So we take X 112 minus mu, the population mean 120, over the standard deviation sigma 6. So negative 8 over 6. And that's going to give you, when you calculate that, it's going to be, if you divide this out, don't use your negative sign, and then 8 over 6 is 1.33 repeating. It's actually negative 8 over 6, right? So negative 1.333 repeating. So again, you need to round. It didn't come out exactly. So you're going to have to round to the hundredths place so we can use the table. In the hundredths place is a 3. You look to the right as the thousandths is a 3. So we don't round up. We keep it the same. We call that negative 1.33 as our Z-score. That's not our answer, but that's going to get us to our answer. So we're going to look up on the negative z table, negative 1.33, and get the area to the left, which is what we want. So row negative 1.3 over to 300s, negative 1.33, and I'm going to get an area of 0.0918. The area to the left of negative 1.33, 0.0918. So I'm going to put that in the table here in the drawing. Now that's not our final answer. We're almost there. That's the probability that one concert will have a decibel level of less than 112. So what's the probability of 100 concerts doing that? Well, that's the probability or the proportion. You can use that as that idea too. So we're going to take that probability of 0.0918 and we're going to multiply that times 100 concerts because that's the probability of a one concert. Then we're going to multiply to have 100 concerts. So that's going to be about 9.18 concerts. So you can't have 9.18 concerts. Is that closer to 9 or 10? You can only have a whole concert. That's closer to 9 because in the, excuse me, in the tens place is a 1. So it's about 9 concerts out of every 100 you can expect to have a lower decibel level than the average, than the mean. So about 9 concerts. You're going to round to the nearest whole number because a concert can't be a decimal amount. Again, Alex should tell you that how it wants you to round. All right, so now we're going to do just a couple more questions. Now we're going to remember in 6.1, sometimes we would go in the other direction, given an area or probability, work our way back to the z-score. So we're going to do that with the applied problems. Given an area or probability, work our way back to first the z-score and then the data value x. And we do that sometimes when we're talking about making like a cut score for a test or some sort of entrance exam. If you want to only admit, for instance, the top 10% of the people who take the test, or maybe the lowest 25% get a special tutoring class or something, then you kind of need a cut score and you've got to work your way back from the area, which it'll tell you where it is somehow by saying highest, lowest, middle, something like that. Work right back to z and then work your way back to x. So what we're going to do is we're going to draw the normal curve and shade the desired area that represents the probability, proportion, or percentile. It will tell you where. There'll be some word like highest, lowest, in between, so you know where to shade. You're going to find the value from the table that corresponds to the desired area. Again, looking up the area, we might have to do a little work to find the area to the left, and then finding the z-score. And then once you have the z-score, you're going to calculate the x value using this formula. And it might, there might be a gobbledygook symbol in your notes. It's x equals z times sigma plus mu. It's the z-score formula just reworked algebraically to be solved for x instead. So it's a little less algebra than putting things in z and having to move everything around. So again, x is a data value. Z is the standard score, which is the number of standard deviations of x, data value x, from the mean. So nothing's changing here in what stands for what. We'll just define them here. Sigma was the population standard deviation. And mu is the population mean. So again, it's really the z-score formula just reworked. So it's solve for x instead of solve for z. So we don't have to do quite so much algebra to move things around on these problems. Okay, so let's go to the problems. We're going to do 2 problems in this section. Example 6.9, Police Academy qualifications. So to qualify for a police academy, the candidates must score in the top 10%. Top 10%. So that's telling you what the area is and it's telling you where, the top 10%, the right tail, on a general abilities test. Assume the test scores are normally distributed, so we can apply our normal distribution, graphs, charts, formulas, all that. And the test has a mean of 200, so there's our mean mu, and a standard deviation of 20. There's sigma, 20. Find the lowest possible score to qualify. Okay, the cut score. So first, let's draw the picture. The top 10%. So we know our mean, mu, that's in the center, is 200. Where would be the highest scoring the top 10%? That would be over here in the right tail. Here. 10%. And so first we want to find Z, and then we want to work our way back to the X. What's the cut score that puts somebody in the top 10% on that test? And so they're giving you the area. If we want to find Z, though, we need to know the area to the left. So we know there's 100% total under the curve. So that means here to the left, if this is 10% in the right tail, in the left, that must be 90%. Now, when we look things up in the table, we don't look up percents, we look up decimals. So I have to convert 90% to a decimal, which is 0.90. And I'm going to add 2 more zeros because in our table, all the areas have 4 decimal places. So 90% as a decimal is 0.9000. So where am I going to find that? I'm going to look up the area. I'm going to look for that on the positive Z table because that's where Z is. And that big number of 90% wouldn't be on the negative Z table. So I'm going to go to the positive Z table, as we worked in the end of section 6.1, and we're going to scan through these progressively larger numbers and hope we can get an exact math. Usually if it gives you something like 10% or 20% or something like that, there's not going to be an exact match. So we're going to go try to find the first 0.9 in the table that we can find, and here we go. It's at 0.9015. That is not 0.9000. It's a little too big. It's about 15 10,000ths bigger than what we want, 0.9000. So I look to the left. That's a little too small, 0.8997, but that's closer to what we want. That's 3 10,000ths too small, whereas this is 15 10,000ths too big. So if there's one that's closer, pick the one that's closer. I'm going to pick 0.8997. It's really close to what we're looking for, 0.9000. And I'm going to use the Z-score here from row 1.2 and look up for the hundreds place. So I'm going to use a Z-score of 1.28. Gives you the closest area to the left of 90%, 0.9000, 1.28. So that's the Z-score I'm going to use. Now I'm not done. Now I have to work my way back to the X, the data value. What's the cut score on that test that will give you that area of 90% people score lower and 10% score higher? So we're going to go back to the X formula, which is X equals Z times sigma plus mu. Sorry, my other book, it used to be in the reverse order, so I just have to check. So here, I'm going to just put all the information I have in there now. So X equals Z, we just found was 1.28, times sigma given was 20, plus mu is 200. So we're just going to go to our calculator. 1.28 times 20 gives you 25.6 plus 200. Which is going to give you 225.6. That's the cut score. And Alex will tell you how it wants you to round. Maybe you can't score 225.6 on that test. You can only score 225 or 226. That would be closer to 226 than it would be to 225 because of the 0.6. But again, Alex will tell you if it wants you to round the answer to the nearest whole number or to keep the tens place. It will tell you how many decimal places to carry. So anybody who scores 225.6 and above is in the top 10%, and I guess would be go to the next step, right? To the interview or whatever the next step is for the police academy candidates. All right, so one more, systolic blood pressure. For a medical study, a researcher wishes to select people in the middle 60% of the population. So that's where we're going to shade the middle 60% based on blood pressure. Assuming that blood pressure readings are normally distributed, so we can apply all our formulas, graphs, charts, all that. And the mean systolic blood pressure is 120. And the standard deviation is 8. So there's mu and sigma. Find the upper and lower readings that would qualify people to participate in the study. So we're going to graph. We're going to draw a picture, as always. And we're going to put in the middle our mean, our population mean of 120. And then we're going to put in the middle 60%. So remember, there's symmetry. And so we want to split this. The middle 60% means you're going to have 30% on each side. 30% here. 30% here. That's the middle 60%. And so what we want to do is find these two z-scores. They will match because of symmetry. It's just one will be negative and one will be positive. So that saves us a little bit of time. And what if we want, and the easiest one to find is the negative one, because it's just easier to find that one and then work our way around. So what we need to find if we want to find this one is we need to find the area in the left tail. So here's 60%. Remember, there's a total of 100% under the graph. So we have to figure out each tail. So 50% on each side. So that means the left side here has, the left tail has 20%. The right tail has 20% because again, we know it's 50% on each side, 100% total. So the easiest one to look up is the one where we already know the area to the left. So I'm going to convert 20% to a decimal, which is 0.20, and I'm going to add 2 more zeros because when we're looking up area, we have 4 decimal places in our table, 0.2000. And I really just have to look up this one because this is going to match. It's just, this is negative, this will be positive because of symmetry. So I'm going to go to the negative z table and I'm going to look for 0.2000. Again, it's probably not in the table. It's probably, we just have to find the closest. So they get progressively larger. I'm just going to find the first 0.2 in the table, which is right here towards the bottom here. So the first 0.2 something in the table here is at 0.2005. That's a little bit too big. It's 5/10,000ths bigger than we want, 0.2000. So I look to the left, 0.1977 is too small. That's farther away. That's 23 10,000ths away from what we want. This is only 5/10,000ths away. So I'm going to pick whichever one is closer to the area I want. By the way, occasionally it's a tie that both of the values are both the same a distance away, like 5/10,000ths. You can pick either one. If it's a tie, you can pick either one. Or Alex might tell you to pick the lower one. Sometimes I think they pick the lower one. I don't remember, but usually it's a tie. You can pick either one. They have an answer tolerance if there's a tie. But this is the closest area. So I'm going to use a z-score of negative 0.84. Row negative 0.84. So that's my z-score on the negative side is negative 0.84, but I also need the one on the positive side. So I have to use positive 0.84 because I'm doing this problem twice. I'm finding what's the value here for blood pressure and here that would allow someone to be in the middle 60% and be in the qualify for the study, because maybe you get paid to be in the study. So again, we have to use this X formula, Z times sigma plus mu, and solve for X, which is the data value, the blood pressure values on the lower and the higher end here. And so we'll do this twice. So we take Z negative 0.84 times sigma 8 plus mu 120. So I'll do this one first. So we'll take 0.84 negative times 8. That gives you negative 6.72 plus 120. Which gives you 113.28. Over here, we're going to solve for X again using the X formula. So we're going to take, sorry, this is X. Let's see there. A COVID brain, I think, right? So we're going to solve for X. So we're going to use this Z and this formula and solve for X. So we're going to take Z 0.84 times sigma was 8. Plus mu 120. So this is going to give you positive 6.72 plus 120. So that's 126.72. Okay. So which values of blood pressure would qualify someone to be in this study? From 113.28 to 126.72 would put somebody in the middle 60% for blood pressure and would qualify them to be in the study. So that's the end of 6.2, the applied problems. Next Monday, when we have class in person, we will go to 6.3 and do a little more complicated applied problems. And then also we'll do chapter 7, just 7-1 session. So again, keep in mind that what you have due this week is you have homework 13 and 14. This was 6.2 is homework 14 and Alex due on Friday night. And that's homework 11 and 12. That's what I meant to say. Looking at the wrong thing. Homework 11 and 12. So homework 11 was 6.1. Homework 12 is 6.2. You have discussion number 5 due in Canvas this week on Thursday and Saturday, your initial post and follow-up point post. And then you should also be looking to start studying for test 2, which is going to be next week, Tuesday, 11/1. That's not next week. That's the week after, right? It's going to be the week after next. Sorry. It's going to be the week after next. So don't start studying yet. So we're not there. So sorry. Ignore that. So homework 11 and 12 due Friday, the 21st. Discussion 5 in Canvas due the 20th on Thursday and the 22nd on Saturday. My brain is not functioning very well. So that's it. I'll see you all next Monday on the 24th at BioPark. Thanks.